Okay. Now that we're back to work. I actually have my other camera working too. You guys are under surveillance at all times. No, that'd be kind of creepy, but no, I don't think we do. There you are. Are you ready? Sine of theta over 2. Sine of, remember I stored it, it's A. Okay, there it is. I put it in my calculator. Okay, 0.525. Don't forget our answer that we just got, which was the square root of, wasn't it the numerator was 1, you have to remind me, was it 1 plus or 1 minus the square root of 5? I think it was minus, wasn't it?
It's 5 minus, wait.
Is it 5?
5 minus the square root of 5.
Alright, it's 5 minus the square root of 5. Got it.
I don't understand why it's 10 on the bottom. Like, where did you get the 10 from?
That is because remember we took a half and divided it in half? You multiply the two denominators. When you divide something by more, like if I take, hey, what's half of a fifth? A tenth. Because you're taking a fifth and dividing it by 2, the 5 and 2 get multiplied. So when you divide by something, you're amplifying what you're dividing by. You're making it even that much worse. And so, or better, however you want to think about it. So there's my divided by 10, right? I want to make sure this is the right answer because if it's we all have to console each other and cry. It worked. So the answer we got totally matches, but it's nicer. I didn't have, remember these calculators, they've been around a long time, but the batteries have not, and batteries stink. Like the batteries on this thing constantly keep telling me they're low, but it's been running forever. Our gold van, the battery dies every time someone leaves a door open, and that's dumb. Okay, so I don't know what's wrong with that battery. We're working on that. Yeah, okay. So should have thought of that. Close the door. Good thinking. And it was Ethan's fault, too. Again, as usual, Ethan left the door open last night and the battery went dead. Good job, Ethan. I love this ambiguous Ethan reference. It kind of makes my day. Cosine of theta over 2. We're going to do this 3 more times, and you got to hang with me. Now, a couple of you who are notorious for asking me questions about this stuff, I have you on my list because I have a feeling you're going to have to go watch the video because you haven't paid a lick of attention. I won't even mention who you are. So, good luck. Now, 1 plus cosine of x, slightly different formula. All right. That's the identity. Don't try and remember it. Don't do anything but just write it accurately. You can refer to it anytime you want. Your job is, again, to replace that cosine. Okay, sine, cosine, and tangent, we've got a thing. We can replace those anytime you want. So just take advantage of that. 1 plus, it's the square root of 5 over 5 again. Goodness, over 2. And we've already dealt with this, so we actually have, I hope, you have easy access to saying, hey, isn't that just 5 over 5? So it's 5 plus square root of 5 over 5 over 2. And there's that, hey, I'm dividing a denominator by another number, so I can just make it 10 in the denominator. Really cool little trick and important mathematical idea. Okay, same thing. Now, in this case, the only reason I put this one on here is that just to remind you, there's a plus or minus in there, and that plus or minus is not a guess. It's because you know the general picture from whence this came. You know that we're up in the first quadrant, and in that particular quadrant, that cosine represents x. It has to be positive. So the plus or minus is for you to determine. Is it plus or minus? Definitely plus because it's to the right. Okay. That's it. That's the moral of the story on those. To the bottom, it only gets better from here. There's another picture. So these are those triangles that you drew in that last test, and your ability to do it become important again. So I got to draw a picture. And that picture, muy importante, says sine of theta is negative 1/2. What does that say to some of y'all? It's negative 1/2. That screams something. It's like, it's down. So if we're going to draw a oh, that's the face is down because sine is y. It's here or here. And then cosine of theta. What if I told you it was less than 0? What would that tell you? To the left, to the left, to the front, to the front. You got it. So we go over here and we dip, baby, dip. There it is. Sine is negative 1/2. That's a lot of information. Because this means opposite is negative 1. A hypotenuse is 2. And hypoteni are always positive. So if I'm going to go to the opposite, that's the negative 1 because the hypotenuse has to be positive 2. You won't make a hypoteni negative. No, 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 no. Better than nooses, hypotenuses. Sounds too violent. Okay. We have a side to solve for, so I'm thinking let's go quick 2 squared. Did you know you can take the hypotenuse squared minus any known leg squared to get the x squared we want? 4 minus 1 is 3, square root it. I think squirt 3 is a wonderful x, but we all know it has to be negative because it's to the left. Nobody tells you that unless you are aware of the context. It's not. It has. So this is what we just got handed. We just got handed the sine of theta is negative 1/2. Now we know the cosine of theta is negative square root of 3 over 2. We have replacements we can put in. There's a movie about the replacements, right? So people, things you can replace freely. Negative 1 over the square root of 3 is over negative square root. That's 1 over the square root of 3. Got it. We have stuff. We have things we can work with. Okay. Tangent of 2 theta has an identity. Your job is to find it and apply it accurately. So the tangent of 2 theta. Now I'm going to copy those. I need to bring them down. Can I bring them down? I'm going to try. No. Can I lasso it? Let me see if I can lasso this. Maybe. Let's try it. No. Where's the circle-y, lasso-y tool? This doesn't have a lasso-y tool, I don't think. Maybe it does. Nope. Nope, it doesn't. Oh well. Different program, different tools. Tangent of 2 theta. Check it out. The identity is, there's 3-fold. No, 1-fold on this one, sorry. Here it is. 2 tan over 1 minus tan squared. 2 tan over 1 minus tan squared. We got it. 2 tangent of x over 1 minus tangent squared. Now, we all know that the tangent squared of x is the same thing as tangent. Let's put thetas in there, by the way. Of theta quantity squared. All right, you okay? There's the identity. That's not the hard part. The cool part is that we now can go in and replace those tangents with actual numbers. And that's how we evaluate this. You put in the stuff we know. So 2 times 1 over the square root of 3. 1 minus, same thing. You could use it twice. It's a twofer. 2 for 1. And then you get to do all the joyous simplifying that you know is in your future. On top, 2 over radical 3. Gotta like that. And down below, if I square each of these, as I should, it'd be 1 over 3. So this becomes 1 minus 1/3. Now, any method you want to choose, I think most of us know it's 2/3, but you could call it 3 over 3 minus 1 over 3. But in the end, it's just 2 over square root 3 and 2 over 3. And we don't divide by fractions. You end up reciprocating. Yes. And that's almost there, almost there, almost there. Cancel. Because the glue is multiplication, so you're good. 3 over the square root of 3, I'm perfectly happy with that. Always have been, always will be. However, you are going to want to rationalize that for a lot of other things like MyMathLab and ACT. So multiply top and bottom by the square root of 3. 3 square roots of 3. over 3. 3's cancel. It's just squirt 3. Okay. There's the whole shebang. That one's nice, but once you get the hang of this, I read an identity, I know sine, cosine, and tangent values, I can just drop them in and replace. Oh, these get really fun. Slick. Slick, slick. I'm going to roll over to the right side just because now I have tangent of theta over 2. When you have a lot of identities, choose the one that fits your situation the best, or choose the one that's easiest to write. I like the bottom one, just because there's no radicals and no negatives. Let's go with that one. Sine over 1 plus cosine. So we're going to do it.
Oh, goodness.
Did we get it? Sine over 1 plus cosine? Done. Replace them. Sine of theta wasn't, that's, can't remember, is it negative square root of 3 over 2? Or negative 1 over the, I can't remember. Negative a half. Dope. I got it. Negative a half. And it's 1 plus cosine, and I can't remember what it was. Negative square root of 3 over 2. Got it. How's that look? Got them? Adding fractions. We are getting good at this. That's 2 over 2 right there. So you got negative 1/2 over 2 minus the square root of 3 over, not 4, 2. Common denominator. Those are 2 fractions, so you're going to multiply by the reciprocal. You got this. That's the process. Getting pretty old school. You're comfortable with it, right? Some canceling taking place right there. And in the end, negative 1 over 2 minus the square root of 3. Now this would be perfectly fine in Sealy land, but you all know that my math lab is going to ask you to rationalize it. So you choose the difference of squares counterpart to make this work. If I multiply top and bottom by 2 plus the square root of 3, you get a squared, if this is a minus b times a plus b, you get a squared minus b squared as a result. So that's 4 minus 3. And on top, what you have is just but negative 2 minus square root of 3. You just distribute the negative. And in the end, that just makes negative 2 minus the square root of 3 all over 1. So it's just negative 2 minus the square root of 3. That's it. Pretty slick. Okay. We're almost to some interesting places. So this is the other, we love radicals. That's the theme of this particular section. And we love the unit circle. 67.5 is not on the unit circle. However, if you can find some way, now we can't add 2 unit circle values. We cannot add 2 unit circle values to get 67.5. No. But what else could we do? I heard something. 135, what would you do to 135? Cut it in half. 135 divided by 2. And that's kind of cool because we know what to do when we have something divided by 2 and it's inside sine, cosine, or tangent. We just did it. We have a way to rewrite it. So we cannot add unit circle values, but this is a big but. That sounds weird. What are you talking about? So cannot add unit circle values, but we can divide them or multiply by 2 in some cases as an alternative. So here goes. Ladies and gentlemen, 135 divided by 2. It's what we do for all 3 of them. We're only going to choose to do one of them. It'll be fine. So sine of 135 over 2 is equivalent to sine of 67.5. And the advantage, though, is we have an identity that says, hey, did you know